You stabbed me first.
Okay, so we've got about the third left to do today. We talked about the vertical line test already, and I'm not going to go ahead and spend a lot of time reviewing polynomial functions since we did so much with those. So here's what I suggest you do, just to get a flavor for reading this textbook as well, because there will be a few times where I assign something to reading, not too often, but once in a while. This is one of those times like what I was talking about the statistics today. So I would go ahead and read page 24 to 25. Now I'm not going to give you an intense explanation of how to read a textbook. If you were going to take like an independent study with me, or if you were going to do a higher level math class, then I actually would go ahead and do that. But I don't think it's necessary. We're not going to read this book that much. It is a nice thing to know, because do you read math books like you would read another textbook, like you would read even a piece of fiction or a piece of nonfiction? Not even close. Like, the technique for doing it is involved. It takes time to perfect. It takes discipline. Let me just suggest a couple notes though. When you're reading this, one time through where you just let your mind wander is not going to do it. You guys know that. You might always, when you're doing math or science or something serious like that, where you need focus, things that promote focus are like a hard chair. I wouldn't be laying down. I wouldn't be thinking about other things if you catch your mind wandering, because I do this all the time. I slap myself mentally. Not physically. I guess if you want to take it to physically, you can, but don't want to mess with it.
We'll show with bruises on our faces.
But you've really got to do this. If you lose focus, you're going to backtrack, okay? So 2 pages may take, usually, I know you guys are all awesome readers, usually 2 pages can take you nothing. It's going to take you 2 minutes. 2 pages of a math book may take half an hour. It depends. Okay, that's for me personally on things that I read a lot of the time. That's how long it takes. Depends on how strong the concept is. Now this, I don't think you need to spend that much time. We don't. But if you see any examples, you need to work them out. This textbook has usually a very good variety of examples. I'll be using there sometimes I won't. But what do I mean by work out an example? Especially, this is a calculus book. It's different than what you've seen.
How they're solving.
Right. They're going to skip steps a lot of the time. You need to fill in those steps, because you're not going to know how they went from one step to the next. You need to make a guess and see if you can fill that in a lot of the time. That is really important in higher level math. Okay? Very important. In this textbook, that's going to be kind of important sometimes. And then I would definitely always read the margins. If there's info, sometimes, like even a biographical thing, even if you read something, for instance, this has just one little piece of information about Euler. I think I've talked about Euler before. I don't know. I forget which class is which.
Yes, you did.
I changed my stuff that I go over, but there's all kinds of stuff about Euler. Euler is a super famous mathematician. The point is, this historical anecdote might get you more interested if you're interested in history, but also it gives you a way to backtrack and remember that piece of mathematics. That's how you create associations in the brain. In mathematics and science, that's super important, associating one thing with another. So those are just some brief tips. I could do a lot more in-depth treatment where we actually went through and read it together, but I don't think I'm going to need to do that in this class. Anyway, so let's talk about some other stuff some of it's on these pages, some of it's not. So I'm going to define a couple functions. F of x, g of x, and I'm going to say, what is f of g of x? What is g of f? 3 halves. Okay. So how do I do this from an analytical function? Remember, in calculus we're going to be working with that rule of 3. What's the rule of 3 again?
It's not the one where you work from right to left, is it?
3 main ideas we're going to focus on. Analytical. In a second here we're going to go to the picture, graphical, and then we'll use a little bit less often tabular. Those are going to come up in different things. So how do you do composition of functions analytically? Well, we did that a bunch, right? So I'm just going to review. F of g of x, how do I write this down? Well, you guys are having trouble saying it to me. G of x should be inside, right? F of g of x, the way you say it. It should be inside, that's the key. Okay. So we're going to go f of cosine of x. Just this kind of notation, very, very big in this class. We'll do lots of things that are this kind of way where something's inside of another. Okay. Put it wherever it goes, 2 cosine x minus 3. Easy stuff. Just a cosine curve, amplitude of 2 shifted. The whole thing's been down 3.
Down 3, yeah, that's what I can see.
It's not 3 to the left because it's not that, right?
-1 is the next.
3 halves.
So that's G of F of 3 halves.
You can do this all kinds of ways. It's up to you. I'm just going to put 3 halves into F right now. If I do that, I get and what else do I need? That, right? So what am I actually putting into G?
0.
Cosine of 0? Not theta.
Why cosine?
Because 3 minus 3 is 0.
Oh, okay, yeah.
3 minus 3 is 0.
Nice.
Cosine of 0 is, of course,
1.
good. Okay. So there's an analytical way to do composition of functions. And this is going to come up a lot. We'll have things that are explicitly composed functions a lot of the time. I think even more often in the class we'll see pictures like this, similar to this. So let's say we've got x and y. I'm going to put a couple different graphs on here. I'm using different colors. Doesn't mean you're always going to have that. Hard to draw this kind of thing. Hopefully we don't have to draw this kind of thing very often. I just wanted to give you an idea of how to do these graphically. I don't know if we did in the past. It's at least as easy though. Okay, let's do that. Yeah, do this one step at a time. Follow the notation. So often in this class you can avoid big logical conditions by just following notation. Yes, we're going to definitely have to make those big logical jumps, but avoid them when you can. H of 3, just look at that individually. Don't even look at this. What's H of 3? Now I'll go from the graph. What's it look like it is? 1. It's right there, right? 3 on H is 1. So this is really just F of 1. So then we use the graph to do that too. What do we get? Looks iffy.
Looks like
It's like 1.5.
Let's say -1. Usually you're going to have better graphs because I didn't just draw them. And this guy, first I should be computing f of 0 because it's like this, but no, just write that down first and then you're not wondering anymore.
So
F of 0 is 0, so h of 0 is 3. Do you want to look at these two pictures and try to abstractly make the jump from here to here? You could, but it's certainly going to be difficult. This is super easy if you just take it apart one piece at a time. Follow the notation, okay? And a lot of times when we see pictures in calculus like this, they're going to ask us to do different things with those pictures. Focus on one little piece of information at a time and see where it leads you, okay? Let me see where my notes are. Alrighty, so we got that. The only other issue that I think that we needed to talk about was even and odd, which I did mention last year. Okay, so even and odd functions. When is a function even?
That
tell
has
me.
the symmetry.
What kind?
The y-axis symmetry.
Yes. Function is even
Good job.
if it has y-axis symmetry. So can you guys give me a common example of an even function?
Cosine.
X squared.
Cosine. Very nice, I like that. X squared, that was the easier one. Very nice. Okay. Does cosine work? It does. It's a good one. Function is odd.
If it does not. You know, if it has x-axis symmetry.
I don't think so.
I try.
What's a key, like, simple odd function I like to think of?
Sine.
Tangent.
Sine actually works.
X third minus x.
Think of something simple. X squared is even.
X to the
cubed.
third.
F cubed is odd. X cubed looks like this, right? That's x cubed. What's the kind of
It has
symmetry it
reflective.
has? It's what? It's not y equals x symmetry. That'd be like this, right? It's not
Rotation.
symmetric like that. It's not symmetric
No.
across any line. This point has a partner.
So
Origin symmetry.
Origin symmetry. There you go. Good, Austin.
Oh yeah.
This won't come up, I don't think, too much this year, explicitly, but there are lots of theorems in different calculus classes that have to do with the function being even or odd. Sometimes.
How do you determine that though? Like, if it's not like x to the third or x squared or something,
It's not just
and
something
you
you
don't,
don't-
like, what if you can't graph it? How do you determine it?
Good question, let's see. So how about this? Is that even odd or neither? Because some things are just not either.
I know this one I looked in the book. I should have known that. But I don't understand, so it's okay.
How do you check?
You can factor it.
Brett's already thinking factor automatically. Good reflex, I like that. You could go x. True. Is that gonna help you detect this though? That'd be good though, I love that reflex, I love it. Okay. If I want it to have origin symmetry, that means when I put in this x value, I had better get the same thing out here. So if I get f of x here,
So if you put it in a negative x value.
I should get the same thing as when I put in a negative x value, but what do you get there? Negative f of x. You can derive that rule from the picture if you know what x cubed looks like. I don't remember that rule. I never remembered that rule. It's so easy to confuse. The rule for detecting odd is you see if f of the regular x, that point, is equal to what, Todd? Negative f of negative x. That's the rule. If you forget that rule, look at x cubed. The rule comes from that. You can derive it real quick on the spot. The rule for this is f of x is supposed to be equal to, let's draw a picture. We said x squared or cosine, let's do x squared because it's a little simpler. So if I put this x value in,
f of negative x.
and I get this f of x value right here, what's it supposed to be equal to over here?
F of negative x.
F of negative x. The picture tells all. Remember the picture, don't remember the rule. You should be able to derive the rule from the picture. That's much more natural.
So on number
It'll
one,
last
if
a
you
lot
were
longer.
going to use the rule,
Okay, doing it. Let's just see.
So you think-
For either one of these, don't I need f of negative x? I might as well just calculate that and save myself some time. So f of negative x, let's see what it is. We go negative x, put that in the cube, minus a negative x here. If I do an odd number negatives,
Still negative.
still negative.
But it's a plus, so
Is that the same as the original?
no.
So that means it's not.
even.
It's not,
Not
even, but
even.
it is odd because that's a negative of the.
So she's already looking at this and she says, okay, if I just negate that, if I pass another minus, nice to color code here, isn't it?
Jeez, I think.
Okay. Another minus, that's what Caitlin's saying. So, better not put an equals there. I better say this is going to be negative f of negative x. Then I'm going to get x cubed minus x. That's the same as the original, so this guy is odd. You guys try this one real quick and we'll be done. Okay. Let's see, I had 2 minus sine of x. Is that even, odd, neither? What is it?
It's neither, isn't it?
I got it. It's even.
I got odd. Neither.
A whole variety of answers. Okay, just like last time, let's compute g of negative x. If we do that, we get 2 minus the sign.
Of negative x. And the negative pops out.
The identity says signs stay, if you've got a negative inside, the negative does pop out, so
So
you're
it's
gonna
2
get
plus sign of x.
2 plus sign of x, so it's not
Not even. But it's also not
If
odd.
you put a negative in
because
front,
Negative, it's not the
if
same.
you do negative g of negative x, you put another minus in front here. It's not gonna work either, is it, Kate?
Because you get negative 2.
That part looks good, that part's not good.
So you get.
This is neither.
So when you just. So when does the negative come outside of the parentheses with the x?
It's an identity. Those are some of those basic identities.
Oh yeah. Okay. Yeah. Never mind. After.
Now, every identity we learned in trig, do you think you need them all in the AP exam? No, you need to know some basic ones. They're the ones that I've tested you on the tests with. So how did I make that decision? Mainly I made it from the AP decision. Okay, like what are things that might come up? Things like that.
The Pythagorean.
Sine of x
The
plus
Pythagorean
cosine of x
identities.
equals 1.
And maybe a double angle, but I bet you could always get away with not having to do that. But if you know your Pythagorean and these identities and just the basic ones, usually that's good enough
So it's
on
cosine.
most problems.
If that was a negative x with the cosine, then they would automatically drop it. And then,
yeah.
because
It'd be-
the
so
cosine
be-
is a.
It'd be 2 minus cosine of
Okay.
x.
So it'd be even.
Okay.
So this, let's think about this as a picture. Guys, what's this look like? Let's confirm that this is neither from the picture. What's this look like?
Up 2.
Up 2, so I'd move the axis up here, draw my axis.
And then it's flipped, so it goes like back.
Sine of x would go like that. What's the period?
But instead
This
of
one's going
up, it
minus.
goes down.
Like that? Is that this way good? Doesn't have that kind of symmetry, does it? Can you like go across the origin? Of course not. Doesn't have any good kind of symmetry.
Dumb.
Now Brett was saying cosine did. If you had 2 minus cosine of x, that would work. Think about what the picture would look like. I think that would be symmetric this way. Okay. Alright, I think we're done. So you guys have the assignment?
I have a question.